Here, in this geography of silence, time stands cold. The Arctic night and midnight sun frozen by the same unseen force. Man has come as a humble intruder to this lonely stillness, his presence only an echo on the icy wind. But he has come to stay, not as an invader of this chaste wilderness, but as the watchful sentry of the polar vastness. It was 1952 when a group of top American scientists was called upon to study a most serious problem in the minds of defense analysts. The problem, how to protect the North American continent against a surprise air attack from the most logical attack route over the polar cap. Under the code name of the Summer Study Group, the scientists assembled at the Massachusetts Institute of Technology in quest of a feasible solution. Their in-depth studies culminated in a recommendation of a chain of radar stations which would form an electronic fence across the entire North American continent. In case of an attack by hostile bombers, this distant early warning system, strung out above the Arctic Circle, would buy us time, very precious time. It would buy us enough time to react, both defensively and offensively. This deterrent to aggression was given the acronym DEW line. In 1952, the existing electronics equipment wasn't suitable to the extremes of Arctic weather and atmospheric phenomena. But the challenge was accepted, and in less than 1 year from the DEW line's conception, the first prototype station was constructed at Streator, Illinois. The scientists started from scratch and invented as they progressed. Equipment was individually designed for the alien Arctic. Most components were handmade. Barter Island, Alaska, 240 miles above the Arctic Circle, was selected for the first experimental site in the far north. It was to act as the nerve center for the experimental DEW line. The Air Force began a massive airlift. Under a tight security lid, men, machinery, equipment, and materiel were assembled near this Arctic fur trading post. In all, 3 prototype stations were installed in the Barter Island area. These prototypes supplied the background knowledge used for the ultimate design of all DEW line facilities and for the technical equipment. It was here that the scientists developed scatter radio broadcasting. Radio waves are refracted from the troposphere to the Earth, where they are picked up by precisely sited parabolic antennas. Today, this troposphere scatter system is the prime means of long-haul communication along the DEW line. As a result of the studies and experiments, it was agreed that a feasible and practical solution had been reached for the construction of the DEW line. The distant early warning system would extend from Cape Lisburne on the northwest tip of Alaska to Cape Dyer on the east coast of Canada. This integrated chain of radar and communication systems would ensure us the earliest possible warning of the approach of aircraft over the polar regions. In December 1954, the letter contract for construction was released. The target date for completion, July 31st, 1957. Thus began one of the most monumental construction projects in history. A base of operations was established at Point Barrow at the northernmost tip of the United States. During World War II, the Navy had established a camp here, and now it offered a working headquarters and base of supply for the DEW line project. Warehouses, barracks, and a landing strip were a few of the essentials made available. With only 2 short summers for construction, time now headed the list of obstacles. Permanent quarters with heat, water, and electricity had to be ready for installation of electronic gear before the end of the summer of 1956. In a heated hangar at Point Barrow, the first prefabricated and pre-insulated housing modules were assembled. then secured on sled-like bases for transport to dew-line sites. These cat trains, along with the construction crews, worked their way to the dew site locations by following trails marked by airdrop flags. Design and construction proceeded concurrently. The electronic equipment, new buildings, and outside plants were constructed directly from breadboard models. There were problems in every phase of the operation. Problems that were eventually solved. In a remarkably short time, radar, communication antennas, and housing modules began to appear on the bleak Arctic landscape. In 1953, the Alaska experimental line became operational. Construction of the Canadian segment posed so many obstacles that, by comparison, the problems faced on the Alaskan segment seemed trivial. For one thing, it had to be constructed in an uncharted wilderness. There were no roads, no docks, no airfields, not much of anything. There were no dependable maps which could be used for scientific sighting of the station locations, so extensive aerial photo mapping was undertaken. Ground survey teams leapfrogged across the Arctic. Each site was selected, surveyed, and laid out to exacting standards. The system called for precise site selection. They had to be chosen for strategic location rather than for easy accessibility. Procurement and logistics presented monumental challenges. There were no hardware stores in the Arctic. Every item, no matter how small, had to be purchased and delivered in whatever manner the Arctic climate permitted. Somehow it all got there. By plane, parachute, ship, dog sled, you name it. At the peak of construction, 25,000 people had been transported into the Arctic wastes to build this 3,000-mile line of overlapping electronic surveillance across the North American continent. was completed on schedule. This magnificent achievement could not have been possible without the historic cooperation, trust, and understanding of the U.S. and Canadian governments. On the contracted target date, July 31st, 1957, the entire line was turned over to a civilian contractor for total operation and maintenance. 2 weeks later, the DO line was formally accepted by the United States Air Force. With the DO line operational, we now had a link of electronic surveillance and communications extending across the lengths of Alaska and Canada. Some 50 stations dotted the Arctic wasteland. 6 main DO stations with data centers manned by military personnel acted as hubs for the detection and identification of aircraft. The filtered data was reported to the Combat Operations Centers at NORAD in Colorado Springs and at North Bay, Ontario. Between the main DO sites, smaller auxiliary stations, or AUX sites, were spaced approximately 100 miles apart. In 1961, the line was extended. With the cooperation of the Danish government, 4 sites were constructed across Greenland, linking the system to England via Iceland. These auxiliary sites are located in some of the most desolate areas known to mankind. Because of their locations on the ice cap, 2 sites posed unprecedented problems for DO line engineers. In resolving these problems, these sites had to be constructed from a very unique design. One site was constructed on a mountaintop, 4,700 feet above sea level on Greenland's west coast. The feasibility of a landing strip was negative. To this day, the only aircraft able to land at this site are choppers, weather permitting, that is. 2 sites were constructed on the Great Greenland ice cap. One is located at an elevation of approximately 7,000 feet. The other is at an elevation of nearly 9,000 feet. Anyone working very hard at these altitudes can appreciate some of the problems of breathing. The only way to reach either of these sites is by ski-equipped aircraft. Each of the sites located on the Great Ice Cap has a composite building which houses the principal activities of the station. The buildings are supported on 8 columns and elevated about 20 feet above the surface of the 2-mile thick cap. Each of the columns has a lifting and leveling mechanism for raising the building to overcome the effects of snow buildup. The 4th Greenland site was built on Kulusuk Island, some 35 miles off the eastern coast of Greenland. A 5-mile road connects the site to an airstrip near the beach operational area. This island site is perhaps the most picturesque of all the DO line sites. It is also susceptible to a most violent climatic phenomenon. Winds have been clocked up to 200 miles per hour, and on several occasions have caused severe damage to the radome. With redesigned, heavier, and reinforced members, the situation seemed to have been remedied. Sandestrom Air Base is used as the hub of logistics operations. Located at the end of a fjord, only 7 miles from port facilities, it is well suited for support to the 4 DO line sites. The Greenland link became operational in October 1961. Now 3,600 miles in length, operational control of the DO line was facilitated by dividing it into military sectors. Contractor administrative control is handled separately in the areas of Greenland, Canada, and Alaska, with the main stations collecting surveillance data from all sites in their sector. Brevity code names are given to all DO stations and reflect their geographic location. But here on the DO line, where all sites are manned primarily by contracted civilians, man does not live by code names alone. DO liners live in a world of their own.
Cairn is one of the 4 main sites in the Canadian portion of the DO line. I have been here 11 years and certainly have no regrets. I guess initially I was attracted to the DO line because of the financial remuneration. I don't think, however, there is just one reason why one remains here 11 years, but rather a number of reasons. The North, for one, is simply a place that grows on you after a while. It can be lonely at times. Then it's so beautiful and so peaceful. Far removed from the pressures of down south.
Military personnel are on board at the main due sites only. In Canada, the military consists of 5 Canadian Forces personnel, usually 2 officers and 3 enlisted men, and 2 United States Air Force officers. The senior American officer is assigned the technical representative of the due system office chief. He is the Air Force's liaison with the on-site civilians.
There are presently 6 Air Force technical representatives located on the due line. These 6 individuals are stationed at all main sites and are responsible for visiting each one of the auxiliary sites and main sites once every 3 months. During this inspection, we monitor the contractor performance, and in essence, we evaluate how is the government getting their money's worth out of the contractor. These people are also responsible for checking all areas: communications, electronics, vehicle maintenance, civil engineering, or runways, anything that might come up as any kind of problem area. And in this aspect, we sometimes work out of our chosen career field, such as myself being a civil engineer. I may work on communications or supply. But it becomes a rather broadening experience for the average young officer on the due line. In addition to the technical representative, we have other teams up here which come through and also monitor the due line's performance. We have the Contractor Performance Evaluation Team, or CPET as we call them, and we have the Arctic Star. The CPET team, 5 individuals assigned to the Air Force, with an Air Force commander, officer type, and 4 enlisted men, who are specialists and technicians in their areas and do an in-depth study of each site at least once and preferably twice per year. The Arctic Star is a conglomerate of ADC people and contractor personnel who visit the due line to get an in-depth knowledge of exactly what is going on up here and for better information on monitoring the contract.
Tow and salvage is...
The 2nd Air Force officer works as a data center officer, sharing this operation with the senior Canadian officer, who also wears the hat of sector military commander.
70 north, 97
Depending on the
north,
situation, one or the other, or both, might be on duty.
The main function of the data center is to collect, display, filter, and identify all airborne objects within the sector, and that's the same with all the sectors, this one being Cambridge May. And that comes in on data on both main site radars and all the auxiliary radars.
I deal with scheduling the controllers and the general upkeep of the place, and making sure also that the other radars, pin 3, pin 4, cam 1, 2, and 3, all can do their job operationally. And if that's done, then I'm doing a good job.
We also coordinate search and rescue, and this is a prime function in the north now with the increased traffic. And of course, we monitor all traffic regardless of direction, and this, although we're not expecting aircraft to go down, we are prepared if they do go down to know exactly where they are at all times.
I'm also the a regular data controller, as is the major, the warrant officer, and the 3 sergeants that are here. We take turns doing the shift work here.
We work very closely with the American Data Center officer, who is part of my staff. This really personifies the close relationship we have between Canada and the United States, both governmental and military.
It's quite a different experience too, working in a different country with a commander that's not a regular USAF. It's something that not too many people get a chance to do. Working with a Canadian major and the Canadian Forces system is quite an experience. It's gratifying. You learn a lot. Find out, just, for example, what is the position of a warrant officer, or found out, for one thing, Canadian Coast Guard is civilian. It's a civilian outfit. There are numerous things about the Canadian government that you learn up here, about the Canadian system of voting, about the Canadian system of taxation, which is a little heavy.
Intermediate stops. Cam 1, Cam 3, and Cam 5. Proposing off at 14:30 total. Elapsed time, 4 hours. Alternate will be Fox 2.
Weather is everyone's concern in the Arctic, and the dew stations supply weather data to all interested parties. Navigational aids and dew line landing strips are often used by outside agencies. In many instances, dew line aircraft have been used for the medical evacuation of Eskimos and other dew liners. Third-party support is provided to many agencies which do not participate in the operation of the dew line. Each year, an average of 150 of these agencies benefit from this support. Geologists, research on the elusive polar bear, the muskox, caribou, and other wild citizens of this remote and mostly frozen world. At Cam, Maine, a marine biologist uses scuba gear to study algae growth in the polar seas. What could be more important to mankind today than to have such a remote frontier base for learning more about himself and his planet? Unless, well, of course,
working on the dew line is not all that bad. Besides, we have recreation facilities, especially at Cam, Maine. We have fishing during the summer months and even during the winter when the weather starts to warm up, especially in the spring. Get out and do a little ice fishing. During the summer, with the 24 hours of sunlight for about 6 weeks, we're able to get out and fish pretty well any time of the day or the night, and especially it makes it nice for people who are working shifts. They can come out after they come off a shift, even if it's at midnight, go out, do a little fishing, and there's no worry about not catching fish because there's plenty of fish up here at Cam Main.
One of the most important keys to sustaining dew-line operations is the powerhouse. The number of diesel generators and their power output varies at the sites according to mission needs. They have a dual function of supplying the electrical energy needed, and their exhaust systems provide a heating source for the module trains, even when the outside temperatures dip to 40 or 50 below. It's shirt-sleeve warm inside. There are 3 depot-level maintenance shops on the line. They're located at Bar, Maine, Fox, Maine, and Sondestrom Air Base. Each has the machinery and equipment necessary to take care of just about every need. Instrumentation plays a crucial role in the dew system. 3 test and calibration centers service precision measuring equipment for the entire line. The centers are located at Powell, Maine, Cam, Maine, and Sondestrom Air Base. Although the dew system is basically self-sustaining, resupply is its lifeline. Continuous resupply is provided by aircraft flying up to the line from down south. Contract jet aircraft are used to fly this vertical airlift. For the individual on the line, the most important items coming up on the vertical airlift are mail, movies, and food. How their importance ranks depends upon how a man rates his immediate needs. To the station supervisor, everything airlifted is important to his operation. Everything from electronic equipment to laundry soap. Once the shipments arrive from down south, everything is sorted out for delivery to other sites along the line. This operation is known as the lateral airlift. Except for the 2 ice cap sites, contract aircraft fly men, equipment, and supplies laterally across the dew line. The ice cap sites can't be resupplied by the annual sea lift, so everything must be flown in. The sites are serviced by ski-equipped Alaskan Air Command C-130s, flying out of Sondestrom Air Base. One of the most critical resupply items is POL, petroleum, oil, and lubricants. The annual POL lift to Die 2 and Die 3 takes place during the spring. Each station requires about 600,000 gallons to sustain operations for the year. Dry cargo is also delivered to the ice cap sites on a regular basis. This includes fresh vegetables, eggs, meat, and all the goodies needed to feed men at isolated sites. The one thing that doesn't have to be flown in at any dew site is fresh water. Most sites get their water from lakes and streams. On the ice cap, they make their own, and the supply is inexhaustible. Since the dew line became operational, logistics has been a monumental challenge. The success of the entire program depends heavily on a constant supply of replacement parts, perishable and non-perishable food, construction materials, fuels, and lubricants. Once a year, between late June and September, the Arctic ice breaks up enough for ships to resupply most of the dew line sectors. Often, icebreakers have to be utilized. Sea lift operations are segregated into 4 distinct areas, all with the code prefix of PACER. The annual sea lift consists of barges, tugs, cargo ships, oil tankers, and helicopters which deliver thousands of tons of supplies. And of course, yes, indeed. When the last of the ships are gone, everyone settles down for the long, dark winter. The midnight sun soon dips below the horizon to stay, and the Arctic night nearly stretches around the clock. Chilling, bone-freezing whiteouts and blizzards become almost commonplace, which is the time when one thing is feared above everything else. Must be extinguished in a matter of minutes, lest it deprive them of their only life-sustaining shelter in a frozen world. Such is a brief look at a strategic defense system that is constantly evolving to meet the challenges of an ever-changing geopolitical environment. The DO system, integrating with the triad of strategic offensive forces, the manned bomber, the sea-launched ballistic missile, and the intercontinental ballistic missile, plays its own vital role in support of these major deterrents to possible aggression. Lifeline of early alert and warning, of rapid communication, far-flung guardian of freedom. A special breed of men live and work on the DO line. It is a different type of life, a faraway, lonely, silent world of space. Space. And more space.